so I think it's all about chasing that optimization and looking for the last fraction of energy. There's a lot of noise out in the world in terms of both the automotive road car world, or the mobility world, I should say, and the motorsport world onto what is the future of propulsion that we're all going to have. Is it synthetic fuels? Is it electric? Is it hydrogen? Is it going to be hybrids and a combination of all of these things? And I'm not convinced that there's any single person on the planet who can truly say that they know what the future is. I think it is a tricky time for the entire industry to work out. But I think where motorsport comes into play is we can help to accelerate some of the answers for the outside world. So, for example, if you look at the hybrid engines that have been running in Formula One since way back in 2014, so a decade ago, they had the ability to use, the 50% of any of the fuel was burned to produce energy. Now, if you look at the combustion ratio of most petrol cars, they're in the low 30%. So already, actually, the Formula One engines are the most energy efficient engines on the planet and have been for the last decade. Then you look into things like the hybrid systems, the actual batteries for 2026. F1 cars are going to be 50-50 in terms of battery, electric power, and internal combustion engine. If you look at the way, we're innovating with synthetic fuels and with sustainable fuels, for example, in the World Rally Championship, in the British Touring Car Championship. So really across the board, not just at Formula One. Again, it's low volumes. It's therefore, and not as price sensitive. You're able to sell the fuels at a higher price to you would to Joe Blogs on the street, and therefore there can be a test bed. And the more we test it, and the better we can develop it, it'll bring the price down to potentially the consumers on the planet. I was one of the first drivers in Formula E. I took part in the first championship back in 2014, and I've been involved in the championship on and off ever since. And it's been fascinating to see just the rate of development of the cars. Now, the batteries themselves are supplied by a single supplier, and the chassis and the base car design is again supplied by a single supplier. But I think what Formula E teaches the companies involved in the sport, the manufacturers like Jaguar and Porsche and all these people, Stellantis Group, of course, is how to optimize it. And really, how do you absolutely eke out every little bit of energy out of that battery? How do you get the software to produce the energy in a way that it's used on the road in the most efficient way? And really, that trickle down know-how will come into the road car industry. In Formula E, you've got 11, well, now 12 actually, very, very competitive teams, and they're fighting for mere tenths. And if they're able to just through the software find a better way to find a bit more performance, then they emerge as winners. And so I think it's all about chasing that optimization and looking for the last fraction of energy. Artificial intelligence is obviously a very broadly used term across all industries today. I think in the motorsport sense, the biggest benefits have come from cost efficiency. When you think about going back into the late 90s or the early 2000s, the teams didn't have the simulation tools. They didn't have the driver in loop simulators that they have today. So they were reliant on going out onto the track and spending millions for the cars to be pounding round and round and round and round, for the drivers to be collecting data and information for them to understand how to improve. Today, a race team is able to run 8 billion different scenarios ahead of a Grand Prix weekend on what the potential combinations can be in terms of car setup, in terms of strategy, in terms of what tires to use, and all these little options. And then as the weekend unfolds, they can narrow it down through all the tools that they've developed. In terms of the simulators, for example, the drivers are able to spend several hours driving the cars in a virtual world, and using the predictive tools to try and understand what's the best setup, what's the best way for them to approach a corner, how exactly to turn the wheel, what part of the track to be on. So there's a whole range of methods in which they can learn in advance before they go to circuit, and waste a lot of time and money, and practically energy and fuel. So I think that there's two benefits. One is primarily really in the biggest way it's been cost efficiency, but you have to say from a sustainability standpoint as well, there's a huge saving on that side as well. Formula One is such a data-driven sport today. The cars are producing gigabytes worth of information after every Grand Prix, and there are millions of data points across that grid between the 20 cars. Now, that data needs to be filtered down, and there's obviously that's where the human element comes in. It's about prioritization. It's about understanding which bit of data is important, that is going to really make the biggest difference to our performance or to reliability, or to make it more user friendly for the driver. So I think there's data is absolutely important. If you were in a financial institution, for example, you know, the more data you can gather in terms of what the markets are going to do, in terms of what the consumer behavior is going to be do, in terms of the risk profiles, for example, if you're customers, if you're in investments, you know, that helps you paint the picture of what to do with the money. But ultimately, the human element of how to interpret that data is still critically important. And to me, absolutely, the engineers are heavily reliant on data, but there is still a great deal of emphasis on experience, human instinct, to make sure that they use the data in the right way, because you can get lost. There is just so much information in F1, you can get lost in the noise, and that's where the human element comes in.